This is translations and vectors. So translations are actually one of the easier transformations to perform, but unfortunately they have one of the strangest sounding definitions. So the definition says that a translation is a transformation that maps every 2 points P and Q in a plane, 2 points P prime and Q prime, so that the following properties are true. The length of P prime is equal to the length of Q prime, and segment P prime and segment Q prime are parallel or collinear. So this is a really complicated way of saying that every point is moved the same distance and every point is moved in the same direction. So every point is moved the same distance and the same direction. So when you look at our object, every point in our object is moved the same distance. So that's our number part, and the same direction. So we often describe translations using something known as a vector. So a vector is a quantity that has both direction and magnitude, which is size, and that's how we translate in a direction over a certain distance. So a vector, when it is drawn, so if you look, so I'm going to draw my vector with points P and Q. So it has a point P. This is my initial point. So whichever one comes first in the name is your initial point. So this is where your vector has to start. And then it has a terminal point. So the terminal is where it ends. So this is our ending point. So it's kind of this weird, strange hybrid between a segment and array. So notice that this is not a full arrow, it's only a partial arrow. So we don't keep moving beyond this point. So like a segment, we have two ends, so we have two endpoints. And like array, we have a direction that we have to go in. The difference is that with a vector, that we always stop at our second point. So it has a definite start and a definite stop, so it can measure the distance between them. So in a segment, it really doesn't matter whether you're looking at P to Q or whether you go from Q to P. It's the same distance, but there's no restriction on direction. It doesn't matter whether I look at it from left to right or right to left. Vectors have that definite directional thing. Array also has a definite starting point and it has a direction. The difference is that we never stop with array. So our second point in array name is not telling us where it stops. It just tells us which way we're moving. So we don't stop, we just keep going. So a vector is kind of a hybrid between a segment and array. So like array, it has direction, and like a segment, it has two endpoints. There are a couple of different ways that we use notation when we're doing translations. So we have coordinate notation. So this is where we say our image point is transformed into our pre-image point is transformed into our image point by this set of calculations. So we take our values from the pre-image and we're either going to add or subtract a value to the X, and we're either going to add or subtract a value to the Y. So remember on your graph, the X's are the horizontal. So this calculation is going to tell us how we're shifting horizontally. Plus is for going right, minus is for going left. And then our value with the Y tells us how we're shifting vertically. Plus is for up, minus is for down. So in our particular example, we're taking and moving every point 5 units to the right and 1 unit up. So we're taking our ordered pair, and to get our new location, we're going to take every X value and add 5 to go 5 units right. And we're going to take every Y value and add 1 to go 1 unit up. With components, we look at them in what is known as component form. So unfortunately, my notes got a little scrunched up here. Component form looks a lot like an ordered pair, but it has this different set of grouping symbols. So this is a pointed set of grouping symbols. This is not smooth like the ordered pairs. These are pointed, kind of like a stretched out greater than or less than symbol. And all this does is tell us how we're moving. So it doesn't actually show the calculation, it just tells us the number. So there's a horizontal number and a vertical number. So if it's a +5, you would use a +5. If it's a negative or left 5, you would use a minus or a negative. So we use the same numbers. So right 5 is a +5, up 1 is a +1. So these two notations describe the same translation. So one of them tells you how to add or subtract to alter. So it actually tells you the addition or subtraction. The component form just tells you the alteration without showing you the calculation. The translation theorem simply reminds us that translations are isometries, which preserve the length. So my pre-image is still going to be congruent to the image. So we're keeping all of our measurements the same. We're just shifting it around on the graph. So our first example question, we're going to take and describe a translation using both of our different forms. So first thing we need to do is we need to look very closely at the diagram and find the pre-image. Remember, the pre-image is just going to use the A, the B, and the C. So this is the one with the plain letters. Our image is the one that uses the primes. So we have A prime, B prime, and C prime. And if you look very closely, they actually gave you a hint to this, because if you look kind of between them on the graph, they did kind of give you a hint into how we're shifting. So they tell us to start with the one on the left and end up with the one on the right. So our coordinate notation says to take any ordered pair from our pre-image, we are going to translate it into the location of the image. So we're going to take our X value and Y value of the ordered pair, and we're going to do a calculation. So we need to figure out how we're moving this graph horizontally and how we are moving this graph vertically. We're going to use that same information in our component form. It just looks a little different. So instead of having ordered pairs, we have those pointed grouping symbols. And within this, we're just going to tell how we're changing the X and how we're changing the Y. So that's what we need. We need to look at the graph and figure out how things are changing. Keep in mind that when you're looking at the horizontal, that if you go to the right, it's positive, left is negative. When you're looking at the vertical, up is positive and down is negative. So pick any set of points. So I'm going to work with A to A prime. So we only need to look at one point because all of our points shift the same way. To get from A to A prime, I'm going to describe the horizontal and vertical shift in terms of how we would move along the grid. So I need to figure out how to go left or right and how to shift it up or down. So keep in mind of our directions. So we are going to the right, and that is 1, 2, 3, 4, 5. Right is a positive, and our count is 5. So +5 is our horizontal shift. We're going up a count of 2. Up is positive, the count of 2. So +2 is our vertical shift. In the next problem, we have been told a coordinate notation, and we have to find an ordered pair. Pay close attention to which one you're asked for and which one you're given. So when we are asked for the image, we're asked for the second part of our notation, and that means that this 4, 2 is our pre-image. So this one just uses our notation as stated. So we're going to take the 4 and 2 and we're going to transform it into our new location by taking my x coordinate of 4 and subtracting 5, and then taking the y coordinate of 2 and adding 8. So we're just going to substitute those values in, and we end up with our image at the point -1, 10. So when they want the image, we do exactly what it says in the coordinate notation calculation. However, when they want the pre-image and they are telling you the image location, for this set of problems, we have to work backwards. So I'm going to show you two ways of setting up the same type of calculation. So one way to do this is to actually write an equation. So we are told that my pre-image x value minus 5, that should be a minus 5, is going to equal the -3. And we are told that my pre-image value of y plus 8 is going to equal the -4, and then all we need to do is solve these equations. So we would have to add the 5 and subtract the 8, and we end up getting that x equals 2 and y equals -12. So our answer is the ordered pair 2, -12. Now, some people prefer to do a little more of a mental math, so you can think of it a little differently. So we can think of it kind of like we did problem 2. So we're going to start out with our point 0, 2, but this time when we do our calculations, we do the opposite operations. So when I'm getting my next ordered pair, I'm going to take the 0 and the 2, but I'm going to do the opposite operation. So instead of subtract 5, I'm going to add 5, and instead of add 8, I'm going to subtract 8. And when I do these calculations, I end up with the ordered pair of 5, -6. So you can either set up an equation and solve, or you can do the opposite operation from the coordinate notation. In the next set of problems, we have been told the vector component form, and we're supposed to translate the triangle. We're using the same triangle for both problems, so I just have the coordinates listed on the graph itself. The vector and component form, my first number tells me how to change the x values, and my second number tells me how to change the y values. So in order to get a prime, I'm going to take -1 and subtract 3, and I'm going to take 2 and add 1, and I'm going to end up with the point -4, 3. To get b prime, I'm going to take 2, subtract 3, and I'm going to take 3, add 1, and I'm going to end up with the point -1, 4. And for c prime, I'm going to take the 4 and subtract 3, and the -1 and add 1, and this is going to leave me with the point 1, 0. So notice that with each of these, all of my x values, subtracted the 3, and all of my y values, I added the 1. Now, some of you are really good at mental math, and that's fine. If you can do the calculations mentally, just remember that your first number is your calculation for the x values, and your second number is the calculation for your y values. So for problem 6, if we do the mental calculations, I have -1 plus 2 and 2 minus 3 for A prime. For B prime, it's going to be 2 plus 2 and then 3 minus 3. And for C prime, it's going to be 4 plus 2 and -1 minus 3. Of all the problems we do in translation, this one set is kind of the most challenging. We've been given the 3 coordinates of the pre-image. We're going to be given 1 image location and try to figure out the vector and component form. And then once we have our vector, we're going to determine the remaining vertices of our image. So in problem 7, since they gave us C prime, we're going to figure out how to go from point C, which is at 3, 2, and translate it to C prime, which is at 3, 4. So we have to look at this as x and y. So what am I going to do to 3 in order to equal the 3? So when we look at this one, it's going to be 3 plus 0 to equal 3. And then we do the same thing for the y coordinates. How do I take my 2 and make it equal the 4? So if we look from 2 to 4, our number is getting smaller, and it is, larger, and it is getting larger by 2. So when we write our vector in component form, our calculations are to do nothing to the x coordinate and to add 2 to all of the y coordinates. Now that we have this, we can go from A, which is at -2, 4, and B, which is at 6, 2, and transform them into our A prime and B prime. So for A prime, we're going to keep the -2 and then 4 plus 2 to get 6. For B prime, 6 plus 0 is 6, 2 plus 2 is 4. Oh, sorry, I have a miscalculation written down here. My C value is, or Y value is incorrect. My coordinate of C is 3, -2. So this should be a -2, and this should be add 6, which is going to change this to 10 and 8. Sorry about that. Nobody's perfect. So always double check that you're writing down your information correctly, because you may do like I did and miswrite something. So let's do it again, and hopefully this time I won't have any miswrites. So in problem 8, we're going to work with point B, which is at 6, 2, and figure out how it got transformed into B prime, which is at 2, -5. So I'm going to look at this one in a slightly different way. So I'm still going to figure out my coordinate notation, but instead of writing out equations, I'm just going to kind of use some mental math. So I'm trying to get from 6 to 2. So 6 is bigger than 2, so I'm subtracting, and 6 minus 2 happens to be 4. So all of my x values, I'm going to subtract 4. to go from the 2 value of the y coordinate to the -5 value of the y coordinate, we're getting smaller. And if I look, 2 and 5 add back together to give me 7. So we're actually getting smaller by 7. So we're going to subtract 7. So now I go through and I do that for A and C. So for point A, I'm going to do -2 minus 4 to get -6, and 4 minus 7 to get 3. For point C, to get C prime, it's going to be 3 minus 4 to get -1, and -2 minus 7 to get -9. In the last set of problems, we have coordinate notation. We're using the same graph for both of them, so we have located the coordinates of each point on our pre-image, and now all we need to do is for every point do the calculation. So for problem 9, every x value we're going to subtract 2, so every x value is going to have a subtract 2, and every y value we're going to add 4. So you should be able to do some mental math calculations. So for m prime, it's going to be -1 minus 2 to get -3, and 3 plus 4 to get 7. For n prime, it's going to be 1 minus 2 to get -1, and then -1 plus 4 to get 3. For O prime, it's going to be 4 minus 2 to get 2, and then -2 plus 4 to get 2. And for P prime, we're going to do 7 minus 2 to get 5, and then 2 plus 4 to get 6. Problem 10, same process, we just change up the calculations. So this time, every x value we're going to add 5, and every y value we're going to add 1. So if we go through, every x value I'm going to add 5, so this is going to be -1 plus 5 to get 4. 1 plus 5 is 6, 4 plus 5 is 9, and 7 plus 5 is 12. And every y value we're going to add 1, so 3 plus 1 is 4, 1 plus -1 is 0, -2 plus 1 is -1, and 2 plus 1 is 3.